Hello, everyone. Good morning. I'm Steven, a biology educator, a science educator, and a researcher. My thesis at De La Salle University built a project based learning plus one module that trains the grade 9 learners in citizenship science, which is primarily in observation, data ethics, and real contributions. I then presented module designs for teaching Philippine ecology and biodiversity at the Asian Association for Biology Educators. Along with my colleagues, my classmates, we analyzed urban versus the non-urban bird distributions in the National Capital Region, Philippines, using eBird, an application, a software powered by Cornell Education in Cornell University. We compared the pre-COVID baselines to lockdown patterns. And my through line into all of these things from the past years is to turn the students into data markers and data makers and our communities into living labs. Thank you for the chance to share this work in cell biology and systems for neurosciences. I'm also grateful to the faculty for the critical lens, to the administrators for enabling evidence driven teaching, and to students for stress testing the ideas. My hope is simple. We should keep turning mechanisms into models, models into insight, and insight into such a better learning and practice. I look forward to collaborating on the next iteration. And this is my talk. It is teaching the brain to think in loops. Here, as a part of the Well-Being and Mental Health Month, and the university celebrating it for a couple of years now, I designed a model-centric learning where students build and test the feedback loops with STELLA, a simulation software, and translate the mechanisms from a particular textbook which is used in cell and molecular biology into a runnable system. So I developed a sequenced set of 31 translational science worksheets that target 7 systems characteristics. So primarily we have components, interactions, input output, feedback, dynamics, hierarchy, and boundaries. You might be wondering about the terms that I've used here. The first term that I've used is translational science. Okay, translational science. It's like translating a language to English into Spanish or Spanish into Filipino and vice versa. In plain terms, it's the process of turning discoveries from laboratories, okay, so what you have discovered from the lab, into a real world solutions. These real world solutions, it helps people to understand what's happening in the laboratories. Think of it as a relay race, okay? The basic research finds how something works. Translational science figures out how to use that or how to use that knowledge to create a test, a treatment, a device, or a program that checks that it's safe, it works in real life, and reaches the people who need it. Recently, there has been discussions about mental health and brain health. I would like to encourage everyone to internalize what these two terms are all about. And why is it important in my presentation that why do we need to teach the brain to think in loops? Okay? Mental health is the established public health term which covers well-being, disorders, services, and social determinants. The concept of brain health is somewhat new. World Health Organization defined it as the state of brain functioning across many different areas like cognitive, okay, how you learn in the class, how you learn mathematics, sensory, how are you using your senses to define or make meaning in your life. For example, colors, for example, flavors, senses, scents, okay, texture, social, emotional, behavioral, and also motor domains, which is happening across the life course. It's often used when the focus is more on the neurological function and lifespan optimization. My take here is that if you are writing for policy or like education or clinical services, you can stick with mental health. And it's the term used by the WHO, PAHO, or the NIMH, embedded in laws, funding streams, and epidemiology. When we switch to brain health, it can sound like trendier, okay? If you know what I mean. We are more inclined, we are more listening to the trend, but it risks narrowing attention to biology and downplaying the context of like poverty, violence, discrimination, or schooling, which drives outcomes. So my advice is to use the term brain health deliberately when you mean, okay, neurobiology, neurology, or for example, our grandparents or our parents and their risks for dementia, stroke, or even lifespan brain function. Don't use it as a euphemism for everything mental, because everyone claims mental health issues and everyone is self-diagnosing mental health problems. So this is another article just this year, March of 2025, by the World Economic Forum, entitled Why We Must Take Urgent Action on Youth Brain Health for the Sake of the Global Economy. So to summarize the information found here, we have the brain and mental disorders which are widespread in youth. About 1 in 7 aged 10 to 19, and most of the disorders emerge before 25. The macro stakes are large. It's global brain health disorders, and they are pegged at around 5 trillion US dollars annually, and with scenarios that could triple by 2030, making this an economic imperative. Okay, not just a niche health concern. It is not just a health concern now. It's more on taking stakes at the economic perspective. Skills are slipping while demand for brain skills are also rising. In this paper, the OECD data shows declines in literacy and flat numeracy even among young adults, while the future of the jobs that we're experiencing will overhaul of approximately 39% of current workers' skill sets within the 5 years. And most importantly, our educational system should be future proofed. That means we integrate evidence based learning strategies, build critical thinking, and buffer the cognitive impact of persuasive digital technology. I have heard one student said to me that there is a scenario way back in the recent earthquakes happened in the province of Cebu, and he or she noticed and included the discussion in my class that the DRRMC have already given a signal to groups of individuals or the Filipino people residing in the area received a text message that an earthquake is coming, and this is widespread. Okay, no one can predict earthquakes. No one can predict a movement of the plates, whether tectonic or volcanic. And I advised her to give me the source, and she said to me that she also found that source from a TikTok or an Instagram reel. Okay, though it is really important to have an access to technology, we must access to youth brain health support, and it must be expanding. There should be school programs that build socio-economic or social-emotional skills, an early intervention, counseling, and very inclusive and culturally tailored tools and services. We also would like to know that not all information that you see online is valid and true. Okay? So in the future, um, I would like to give you an insight about what this pretty lady, the Princess Diana or the Princess of Wales, uh, attracts the diamond ball in the aid of schizophrenia. She said that I was crying out for help but giving the wrong signals in her 1995 BBC Panorama interview. So we are making our schools, our workplaces more brain healthy. Okay, mindful breaks, flexible schedules, neuro-inclusive practices, and also work-life balance is now a stronger motivator of pay than any. So it was all popularized, and it was all coming from the idea before that uh, that the health of the brain is coming from the concepts of phrenology, which is a 19th century theory popularized by Joseph Gall and Spurzheim, claiming that the brain consists of distinct organs for mental faculties that bumps on the skull to reveal personality, intellect, and moral character. And it is now discredited as pseudoscience. It's not true. This is not happening in our age, because we have another field that was developed from these pseudoscience or pseudopsychology we call it the cognitive neuroscience. It asks how the brain does the thinking. We watch the brain at work, like we have scans, we have brain waves, we have safe magnetic taps to measure your behavior and also to build computer models. Different parts of the brain team up. Some keep goals in mind, some store new facts, some focus attention, and some use reward signals to help us learn. And we combine many kinds of the evidence in the clinic, in the hospitals, to avoid overclaiming. So the picture on your right side is a vintage anatomical study of the male human head, showing you the lobes of the brain and the spine, which is coming from a chromolithograph in 1913. This is a part of my study, which I created a nested concentric diagram of the 7 systems characteristics. Everything that's happening in your area, in the society, in schools, in your personal lives is a system issue. Systems is gonna let us think in loops, okay? Thinking systematically. This is a nested concentric systems characteristics. From micro, we have components, boundaries, input, output, hierarchy, interactions, feedback, dynamics. And importantly, we think of the problems that we're facing in mental awareness or mental issues as more of the systemic or unholism view of seeing things. The problem here is that the nesting shows dependency, okay? You can't have feedback without interactions, or dynamics without feedback and inputs. Boundaries set what is in and or out of the model. And there is also another diagram here on your right side, which is a spherical cow note. Why it's here? It reminds us to start with a tractable core, like the inner rings, and then relax simplification as evidence demands. In learning, okay, that means beginning with essential components and interactions. So you must learn the basics. That iteratively, you add input or output, then feedback and dynamics, and finally, situate the model within the hierarchy and explicit boundaries, what's excluded and why. So more likely, the concentric map will help us build order for systems thinking. Okay, that the problem that we are facing now, whether it's mental, whether it's more on cognitive, it's more of making it systematic. This is not always one factor on one factor basis. The causative problems are not only in one one single problem. Okay, only after behavior is intelligible do we place the model in a hierarchy and declare boundaries. So it's not a joke. Okay, it's not a joke that we're experiencing mental issues. It's more of like a discipline. It's more of like how you manage your workload, how you participate in work-life balance, and in classroom. Okay, systems thinking is important because that's how we're gonna get rid of the reductionist approach in learning. That's how we get rid of the traditional or the conventional approach in how we learn things. This is the theoretical framework that I created in my study. Okay, this diagram is tying classic systems thinkers Bertalanffy, Aka, Forrester, and Sench to learning theories of Piaget, Vygotsky, the dual coding, cognitive lobe, in Kolb, Ausubel, Bandura, SDT, growth mindset, then grounds them in the neuroscience boxes like prefrontal cortex, hippocampus, mirror neurons, dopaminergic energy systems, neural plasticity, and semantic memory. And all are aiming at 7 systems characteristics. Before we fully understand any single problem, not just in cell biology, we should better understand what are the components, what are the boundaries, what are the input output, what are the interactions, feedback, hierarchy, and dynamics of every issue. Okay, whether it's mental health or beyond mental health. So in cell biology, and in neuroscience, we associate different parts of the brain. I would not discuss everything here. Okay, it will be an overload of information if I'll discuss this for a couple of minutes. The prefrontal cortex is where you place your executive function and the cognitive flexibility. Okay, the hippocampus plus the semantic memory from Tulving, it backs up cumulative concept building. So you were able to link them into relational schemas. Your brain has hippocampus. Okay, the concepts are folded and founded in your semantic memory. That's the basis. The mirror neurons align with social learning, and in classroom, if your teacher is creating groupings or teams, especially in the laboratory, we we mirror ourselves. Okay, we observe our classmate, build a loop, or troubleshoot problems like in your microscope, for example, or in your calculator, and that can seed own action plan. Your dopaminergic system, dopamine, it's an addictive molecule. It ties to self-determination, like autonomy, competence, and also one of my I founded this theory of productive struggle. Okay, teachers should be happy that students are struggling with their problems in school, in the lesson, in the concepts. Okay, it might be a short win, and autonomy boosts keep students engaged long enough to see dynamics that will emerge. Because if there's no struggle, if there's no difficulty that the students are facing, then there's no learning at all. Next is neural plasticity. It legitimizes deliberate practice. Repeated modeling of input, output, and delays will strengthen the very circuit that supports systems reasoning. That is why learning won't stop after you graduate in college. If you ever that you would like to take another course, go to med school, take graduate school, master's, PhD, whatsoever, it will also give you an edge over your neurological layer, which justifies your rigor in study. Okay, so all of these things, you can take a screenshot of the slide because it's a couple of information that is being presented here. It positions the teams, your groupings, autonomy, you alone working on a problem, and the difficulty or the rigor on top of the prefrontal cortex, hippocampus, dopamine, mirror system, blah blah blah, to m- explicit and measurable class function. Okay, this is a defensible, exportable design rather than a theory collage. It is helpful. Okay, I am making classrooms more difficult, not just difficult without scaffolding. It should be difficult with scaffolding. Okay, the teacher should be on the side to guide you on which way to go. It is not a classroom that the teacher will just let you explore your options and the teacher won't interact with your opinions or your ideas. Okay, it's a directed learning inside the classroom. That's the reason why students often learn more from active learning while feeling they learned less. Perceived learning can be inversely related to actual learning because effort feels hard. Okay? When a class makes you solve problems, to debate, to explain ideas, it feels tougher and less smooth. Okay? You evaluate your teacher in say bad things about him or her. It makes the concept or lesson less smooth than listening to a polished lecture. Okay? It suggests that the hard, slightly uncomfortable work your brain is building is a durable wiring technique. Do you know what I if you understand what I mean? The more difficulty, the more the brain builds new neural frameworks or neural wirings. Okay? Comfort is not equal to learning. Judge by what you can do later. Okay? Quizzes, applying concepts, not by how easy the class felt or what course ratings will say. If students feel better about instruction, they will learn more. Lowering challenge protects mental health. It's a myth. Okay? If you feel better after your teacher discuss a topic, it's not learning more. You didn't learn that much. Okay? In reality, active learning increases actual learning even when students feel they learned less. So, my advice to our educators, to my fellow students, to my fellow administrators, to build pedagogies that are high challenged, high support, okay, the one that measures outcomes, not just comfort. And this one is more likely to become um, the behavior of the generation of the students, like anonymity, invisibility, asynchronicity, and minimized authority fuel what we call as the online disinhibition effect, making students more likely to insult or harass teachers on social platforms. Because mental health is not only about the students feeling ill about their well-being, their appearance. Okay, it's also our administrators. It is also, most importantly, our teachers who is feeling the same way too. And there is what we call online disinhibition effect. They harass teachers online because they can't do it on in person. Okay, so I hope that we should be very careful with how we perceive others of us and how we perceive others. Okay, and thank you. It's a wonderful time. And thank you for thinking in loops with me. And if you remember one thing, make this: systems cognition is teachable. When we ask our students to name components, map interactions, specify inputs and outputs, to watch dynamics over time, locate hierarchy, declare boundaries, we're not just teaching about cell biology or even brain health or even cognitive neuroscience. We're training the brain to reason about complex systems. Okay? And the loop continues, evidence in, iteration out. Once again, thank you so much for listening. Thank you for the time, the attention, and the courage to teach for understanding rather than comfort. I'm Steven Kapilitan. See you in next iteration.